Hi, this is problem 3. Let me just clear my board of problem number 2. Okay, and this is not the problem anymore. So in this problem, we are given a linked list. Output we want to be, we want to reverse every kth node. So we're going to get in and int k. Reverse every kth node. So what does that look like? For example, in we could have 1 points to 2, points to 3, points to null, as well as k equals 2. So what that will look like for us is we want to send out 2 as the head, points to 1. So we've reversed 2 and 1. And then 3 is just one element, so reversing 3 just puts it in the same place as before, and then pointing to null. But let's say we had a 4th element there. What we would be returning is 4 and 3 reversed, and then pointing to null. Okay, so let's get started. I'm going to return a singly linked list as I've defined in my previous videos. I'm going to call the function reverse case. How about reverse every case? And I am accepting a single linked list called list and an integer k. Okay, so first things first, I'm going to make a stack that will hold my nodes that I want to reverse. I'll name it stack. Awesome. And I want to use 2 nodes. One I'll call current. I'll assign it to the head. And one I'll call prev. I'll assign that value as null. Okay, so while current is not null, basically while there are still elements left to go through in our list, set count as 0. This will be reset every time we loop through k nodes. So count is 0. Now another while loop to add k nodes to the stack. So while current is not right, in case we hit the end of the list in here, we need to not do this, not continue, and count is less than k. So while current is not null and count is less than k, I'm going to perch current onto the stack. Perch current onto the stack. Reassign current as current.next and increment count. All right, and then so I've put my nodes onto the stack. They have reversed. Now let's deal with those nodes I've pushed onto the stack. While stack.count is greater than 0, so while there are still nodes left in my stack, if we're at the beginning, so I've assigned prev as null here. So if prev is null. We haven't touched prev yet. Prev is now stack.pop. And I'm going to assign prev is going to be the new head. It's yeah, prev needs to be the new head. Else, I'll connect. So if it's not the new first element of the list, it's gonna just connect to prev itself. So prev.next, so the next pointer is stack.pop. And reassign prev to prev.next. Amazing. Okay, so once we've exited the outer while loop, we need to make the next pointer of the last new element in the list equal to null. And then we said we were going to return a singly linked list. So, I don't want to do that. I want to return a node, actually. Return list dot head. Okay, cool. So let's talk briefly about the time complexity and space complexity, and then I'll walk us through an example. Time complexity, we are that's interesting because we're first adding to the stack, and then so every element will get added to the stack. Likewise, every element will be popped from the stack. So big O of 2n, but that's dominated by just n. So time complexity is big O of n, or linear, and space complexity is big O of n. No, actually, space complexity, what's going into the stack is just k elements every time. So yeah, space complexity is big O of k in this case. And worst case would be that k is equal to 9. Right. So let's walk through an example. Let's take this example, but we'll make it a little shorter for sake of time here. So this would be the desired output if in went 1, 2, 3, and k equals 2, out would go 2, 1, 3. Okay, let's make it happen. So, yes. Let's see, current is, let's not head, so current is 1, prev is currently null, currently. Count is 0. While current is not null, true, and count is less than k, true. Stack.push of current. So how do I want to illustrate this stack? I guess I'll just do, we'll push stuff into our stack like this. So current is pushed into the stack. Current is current.next, so current is 2. And now count is incremented, count is 1. While current is not null, true, and count is less than k. All right, stack.push of current. Okay, push 2 into the stack. Current is current.next, so now current is 3, count plus plus, count is 2. Okay, so we don't re-enter that loop, great. 2 is not less than 2. Well, stack.count is greater than 0, true, stack.count is 2. Prev is stack.pop, so 2 is going to pop off of the stack, and be assigned to prev, because we entered this if block. Prev was null previously. So prev is now 2. List.head is prev. Okay, so that's good. Right now, what we've got is, we'll get rid of that. We have head pointing to 2. Okay, and then come back around. Stack it kind of still greater than 0. We have one element in the stack. Prev is not null. So else prev.next is stack.pop. Prev.next is 1, that means. So brilliant. 1. Prev equals prev.next. Okay, so prev was 2. Prev.next is 1. So prev is now 1. Amazing. Still right. Current is not null because current is 3. Count is reset to 0. Well, current is not null and count is less than k. True. Current is not null. Put current into the stack. All right. 3 goes into the stack. Current is current.next. Okay, so 3.next is actually null. So current is now null. Count plus plus. All right. Count is 1. We don't enter that because current is null. While stack.count is greater than 0. True. We have one element in the stack. No to this. Else prev.next is stack.pop. Okay. So prev is 1. So the next element here is 3. Prev equals prev.next. Okay, so prev is null. That's really not going to come into play here because what we're going to do, you can see that no, prev is prev.next. Okay, undo. Right, 1.next is 3, so got it. Prev is now 3. Yeah, and then 3.next is assigned null, which is great. And return list.head. So return this, and the linked list is this output like we desired. Hey, what's up? Are you there? I don't know how to do this. Hello? Are you there?
Yeah, can you hear me?
Now I can, yeah. How's your flight?
Right here. You just have to speak up because it's loud.